we're going to go on to PriOracle next. This is a team that identified the issue of how do we know what something is worth? Like if you just need to like sell some random thing you've got or whatever, how can you figure out how much it's worth? And it's a definitely simple problem statement. And they found a pretty cool idea of how they can go about it.
Hello, everyone. My name is Josh. I'm here with Vineet, Randy, and Arnold. We created an app we call PriOracle. It's the Oracle of Prices. And we take a user's prospective product listing and we provide them with a fair value price with which to sell their item. We accomplish this by taking an average of a machine learning algorithm and a web scraper algorithm, and we then provide that to the user. So users brought to a login screen where they can log in or log in using Google OAuth. We implemented Google OAuth using the Expo SDK so that we could get around restrictions that we faced while using React Native Link. At that point, the user is serialized into the session using Koa Passport since we use the Koa server. We chose to use a Koa server to make effective use of async await workflow. Once a user is logged in, they can either view their listings or create a new listing. If they choose to create a new listing, then the algorithms will get triggered. And Vineet can tell us a little more about that.
Hey, thanks, Josh. So as you can see, the pricing algorithm is made up of two components. One is the scraping algorithm and one is the machine learning algorithm. So scraping algorithm is basically a program that just scrapes the internet for relevant data and then incorporates it into calculating the scraper price. So for PriOracle, we decided we'll use Amazon, Google, eBay, and Craigslist. So our approach was to use APIs wherever possible, and we would use scraper tools if not. So for Amazon and eBay, we pretty much use their APIs to search the products, whereas for Craigslist and Google, we used Request and Cheerio, which are node modules. Cheerio is especially helpful because it allows you to traverse the DOM, and basically then you can scrape all the relevant data that you need. And finally, we decided to incorporate the pricing algorithm in the backend so that the processing load is not borne by the front end. Now I'll request Arnold to give you more information on the machine learning component of the pricing algorithm.
Thanks, Vineet. So once a user submits a pricing request, that pricing request gets converted into a vector of numerical features. For the MLB t-shirt example, we have only 15 features that are active out of a total of nearly 300,000 features. In the next step, the features are passed in as an input to our machine learning pricing algorithm, which is based on a rich regression model. And finally, that rich regression model produces a price prediction, which for the MLB t-shirt amounts to roughly $8.60. Both the feature extraction and pricing algorithms were trained using a data set of 1.5 million listings provided by Mercari, Japan's largest shopping app. The rich regression algorithm was cross-validated using generalized cross-validation, which is an efficient form of leave one out cross-validation. And all of this was performed in Python using the scikit-learn machine learning library. We didn't do it in JavaScript due to the absence of well-established libraries for that purpose. The big challenge that we faced here was to integrate Python into JavaScript. We used, to circumvent that challenge, we used the child process module provided by Node, and it has a method called spawn, which basically launches the Python script in a new process, and then retrieves the outputs from Python via studout and passes them back to JavaScript. So now we're back to the front end where Randy is going to tell you more about the additional features.
Thanks, Arnold. So the user has submitted their listing, and now this listing will be a new row created within our listings table inside of our Postgres database. And this listing will be associated with the user that submitted the listing. And because of this association, the user can view all of their submitted listings in a separate view, this one. So now if a user clicks on one of those graph icons for an individual listing, they'll see a table and a graph, which will display changes in our valuations over time. And initially, we went with different methods of rendering this information. We tried things like the D3 NPM library, but in the end, we decided to go with the React Native table component and React Native SVG charts NPM modules. And with that, our presentation is concluded. We had a great time working on this project. Thanks for listening, and hope you enjoyed learning about PriOracle.
It's impressive how much data the PriOracle team is even extracting from APIs. I think just that scraping is like a whole separate project I wonder how many times they got our Wi-Fi banned on the various APIs that we didn't even know about. But yeah, I think that's it's a pretty cool problem. And I like that they're really thinking seriously about kind of price estimation. Price estimation. They're just it's such a multivariate problem that there's just so many things that go into it.
Yeah, it was really cool. I mean, they're really tenacious, right? It was like they have their machine learning and they've got like API calls. And for the things they couldn't do API calls, they scraped. It was just like they're getting it from everything they can. Yeah.